Alright, let's start lecture 6 iteration. Before this, we have just covered recursion, which was a major topic for you guys with a lot of difficulty. And even before that, we have learned how to use functions. We have also learned how to make use of if, else blocks. Alright. So for iteration is also commonly known as loops, which is one of the layman terms for it. But let's continue on to see what it is about. Alright. Looking at basic if-else condition, basically you have an if expression followed by a body. Alright, your body here will be evaluated only if this expression is true. Okay, if it's not true, this body will not be evaluated at all. Alright, so if we look at a simple case right here, where I define total to be 0, and my condition is if total is less than 100, which is true because now total is 0, I will run total equals to total plus 1. So now total becomes 1. However, this code will only execute once. The body will only execute once, which is okay in most cases, but what if we want to keep on incrementing the body until it reaches 100, for example, right? So we need to make use of another way of coding. Okay, so we'll do this thing called while loop. Alright, you can see that the structure is quite similar to if else. So while expression, then there's a body. Okay, so this expression, right, basically is a predicate to stay within the loop. Alright, so the body will only be evaluated if the predicate expression is true. So as long as this expression stays as true, the body will continue to execute. It will loop until the expression is not true. Alright. Okay, so for example over here, let's look at the same code but return it with a while loop. Total equals to 0, while total is less than 100, total equals to total plus 1. Right, looks similar, but let's see how the code will run. Alright, we have a flow chart here. So when I start, my total equals to 0. What the code does is that we have a while loop. The code will check whether is the total less than 100. If it's less than 100, it will add 1 to the total and then come back. So this is the body over here. Then it comes back to the predicate and asks, is total less than 100? So right now, total is 1. Okay, so it's still less than 100. It will go on 2, 3, 4, all the way until total is 99. 99 is total still less than 100. Yes, so total equals to total plus 1. Now total is 100, remember? So if total is total less than 100, no, then you end the while loop. Alright, that's how it works basically. Okay, so remember we have done this factorial question using recursion. Alright, remember recursion is to break the problem down into a smaller form until you reach one of your terminating conditions. So factorial 6, remember, is just 6 times 5 times 4 times 3 times 2 times 1. Right? So factorial 6 can be written as 6 times factorial 5, and that can be written as 5 times factorial 4, and that can be written as 4 times factorial 3, and then so on until factorial 1. And we know that factorial 1 is equals to 1, and then we can start to combine them back together until we get 720. Okay, so this is recursive process which some of you have struggled with over the last 2 weeks or so, but we're going to look at while loops now. Okay, so the idea for using while loops is to do this factorial question is to start with 1, then multiply by 2, and multiply by 3, and so on and so forth. Okay, it's important to start with 1 and not with 0, because if you think about it, 0, right, multiply by anything will still give you 0. Alright, so in order to do this, right, we need to initialize 2 values first, 2 variables. Okay, so product and counter. Okay, so the way to do this is that your product, you will always increment it by the product of the product times counter. Then you always need to increment counter by 1. Alright, so let's look at how the code will look like. Okay, so define factorial n. So I define product and counter to be both equals to 1. And the condition is while counter is less than or equals to n. When that is true, my product will be increased by product times counter. Okay, it's important to increase counter by 1 over here. Alright, so this code will keep on running until my counter is greater than n, then it will stop. When it stops, it will return me the product. Alright, but let's see how it works in real life. Okay, let's look at how this iterative process go. By the way, iterative means it will just repeat itself over and over again. Alright, so we have this function factorial n, and then what we do is that we will start by defining this function, and then remember the function is called factorial 6. Okay, so once you come to that, we will go into the function and then see. First thing first, we define our product and counter as 1 and 1. Okay, then the red color line, while counter is less than or equals to n, that is the predicate that must stay true in order for your body of the code to run, right? So let's check. So while counter is less than n, counter right now is 1 and my n is 6. So this is still true. So it will produce my product. So this is just 1 times 1, product times counter. Okay, you must always remember to advance the counter. So counter now becomes 2, counter equals to counter plus 1. Okay, now you come back to the top. You have already finished your one round of your loop. Then you will evaluate again while counter is less than or equals to n. Counter right now is 2, it's still less than 6. Okay, so you run. Then I will multiply again, 2 times 1. Okay, then counter advance to 3. Then now I'm out of the loop. I'm finished one more loop. I'll check again what is my n. N is 6, is still still more than my counter. So you still run. Alright. So if you keep on running this, you get to a stage where right now you will advance your counter to 7. Once your counter hits 7, and then you realize, hey, this is larger than my n right now. Okay, so once this is not true, okay, your loop will have ended, and then you jump to the next line where you return your product. Alright, so your product is 720, right? So this loop will end once the counter is greater than n. Alright, so if you look at this line here, it's important for you to advance your counter. Because if you don't advance your counter, right, if you advance your counter will stay at 1 throughout. And if that's the case, right, you will not be able to break out of your while loop. Alright, because if counter is always equals to 1, 1 is always less than or equals to n. So this will cause an infinite loop. Okay, your code will keep on running. Okay, so you will need to kill it. Alright. So always remember for while loop, right, it's very important for you to advance the counter that you are using. Of course, there's more than one way of doing things. We can also start with n, then multiply by n minus 1, multiply by n minus 2. So just now we are working up from n equals to 1 all the way to n equals to 6. Now we are going down from, let's say, like 6, 5, 4, 3, 2, 1. Alright, so same thing, we will still initialize our product to be 1, but now we start a counter to be n. Alright, and then we will always update the product by product times counter, and then counter will have to minus 1. So when do you think we should stop? Okay, you should stop when your counter is equal to 0 or less. Alright, so while counter is more than 0, I will update my product. Product equals to product times counter, then I'll counter minus 1. Okay, so this will keep on looping. So for like just now we start with 6, right? You will run, first time is 6, counter is equal to 6, so this is fine. You run one time, then counter becomes 5, then run one more time, become 4, run one more time, become 3, run one more time, become 2, run one more time, become 1, run one last time, become 0. Then once counter is equal to 0, this is no longer true, so you will just return the product. Okay? Okay, so with that, let's look at the next thing now. Okay, once you're done with while loop, we can next look at the next one, for loops. Okay, remember if you think carefully about while loops, let's go back a little bit here. Your while loop, right, has the potential of not terminating if you don't set the counter correctly. Okay, so the while loop will terminate when its predicate is false. So that will terminate your while loop. Alright. But in the case of a for loop, right, this another loop here is a bit different. Okay, we have this structure here. Okay, so we have for LE in sequence, then to the body of the code. Alright, so the body, same thing, is the code that will be evaluated once for each element inside the sequence. Alright, then what exactly is a sequence? A sequence could be, for example, like a string, or list, or tuple, or dictionary. Okay, so all these things are also known as iterables. Okay, so basically a structure that can be iterated through, that is considered as a sequence here. Alright, so for example string, we know that we can extract the 0th index, 1st index, 2nd index, 3rd index of the string, so we can iterate through that string. Okay, next we have this loop variable. In this case, the loop variable is called LE. Okay, each item, the sequence is assigned to the loop variable and the body is evaluated once before reassignment using the next item. Alright, so this looks a bit complex now, but we can talk a little bit more about it. Okay, just to note that this LE here is just any variable name that you want to use. You can use for I, for LE, for letter, all is fine. Okay. Moving on, let's look at how we can use a for loop. Alright, so like for example, if I have this simple code here, for car in Singapore, print car. Alright, so what it does is that this Singapore here is a string. The string is, you can iterate through that string. Okay, so for car, what it does is that it will take the first letter, it will take the first character here, right? Assign it to car. Okay, then you'll print car. Okay, so this is the body of my code. So for each letter that is assigned to car, then you will print. Okay, so the first one is capital S, so you will print capital S. Next letter to be assigned. So after it's done in one loop of printing the capital S, you will go to the next letter. Small I now, you will print. So now I is pointing to I is assigned to car, then you print I, and so on and so forth until it reaches the end of the code. Okay, remember I said you can use any variable name in place of car here. Alright, you want to use for letter, for element, that's all fine as well. Okay, so this will run through the code. Alright, so how this works in the case of a flow chart. So the question to ask is it the end of sequence? Okay, if it's not the end of sequence, assign the next letter to the sequence, print that character, then go to the next character. Okay, so if there's a next character, it's not the end of sequence, so continue printing. Print until SINGAPORE. You print the last E now. Is this the end of sequence? No. Print the character. Go to next character. Is there any next character? If there isn't any character, that means this is the end of sequence. Your code will therefore end. Okay, so now we can look at the main difference between a for loop and a while loop. Like what we mentioned earlier, in a while loop, the process in the body is continued until it's repeated until a certain condition is met. Alright, but in the case of a for loop, the process in the body is repeated for a fixed number of times. So when to use for and while loop, right? Sometimes they are interchangeable, but of course you will see that if I'm working with a fixed set of time, if I know I want to repeat my code a fixed number of times, I'll use a for loop. If I'm waiting for a condition to be met, right? Let's say for example, if I want to find the number of A's in a string, I want to continue until I find the 10th A. So in this case, I'll use while count is less than 10. Okay, so that I'll use a while loop. So depending on the condition, you must choose the right type of loops to use. Alright. Okay, next, we have another way of doing a loop. We can also use a range. Alright. So in this case, our structure is for I in range, start, stop, and step. So this is similar to what you did when you were doing string slicing. You're starting from which index to go to which index. Remember, if you want to include the index, the letter at stop, right, you need to go stop plus 1. Okay, and then step is how many what's the spacing on the skip by. Okay, so for I in range, start, body, step, then body. Alright, so this I again is a loop variable. You can choose any variable that you want it to be. Okay, so basically once it's here, the body will be evaluated once for each of I from start to stop -1, incrementally in intervals of step. Alright, let's see how this will happen. Alright, so let's look at this code for I in range 10 print I. Alright, when you only specify one number here, right, this is saying same as range 0 to 10 step 1. Alright, so for I in range 0 to 10, that means I'm printing from print I, I'm printing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I will stop at 9 because remember it was stopped at the 10 minus 1, so that's number 9. Okay, and because I never indicate the step, alright, I will be increasing by 1. Okay, if you want to increase a step, you always must include the start as well. Alright, you cannot just include, like for example, you can just do 10, 1. It doesn't work. Alright. Okay, so let's look at the flow chart again. Alright, so when you start, I takes the first value in range. Okay, so question now, is I within range 10? If it's yes, print the value of I. Then it will take the next number, which is now 1. You will assign to I, and then you run it again. So keep on running until I is 10 or larger, then you will end. Okay, so let's look at this one now. Now we have specified the difference, a starting point and then the ending point as well. Okay, so now we go from 3 to 10. We will include 3, but we will stop at 9. So print I, 3, 4, 5, 6, 7, 8, 9. Okay, so again, if I never indicate the last comma, the step is taken as 1. Alright, so if we look at this 3, 10, 2, now I'll be going from starting from 3, ending at 9 by a step of 2. So I'll be doing 3, 5, 7, 9. After that, you will stop, because if you go more than that, you will be beyond the range of 10. Alright. So let's look at this now. Okay, we have a string now. String equals to Singapore again. For I in range len string. This is another way of defining. So basically what I'm doing here, if you look at range len string, right? Len string is the length for this string Singapore. This is 9 characters, so this is from 9. So this is the same as writing for I in range 9. So range 9 will be from 0 all the way to 8. Alright, print string I. So if I start now, I'm starting from 0. String 0, index 0 is capital S. String 1 is capital small I, all the way to string 8. Okay, because I is from range 0 to 9. So I, the largest value you can take is 8. That means it will return me an E. Okay. So just to reiterate, so you can see that this is how the string can be indexed. Okay, 0 to 8, right? So 0 to len string 9 here over here. Alright, let's look at one more example. When we now say for I in range 0 to len string 2, so start at 0, stop at len string which is 9, step 2, print string I. So now if you look at this, I'll be counting 0, 2, 4, 6, 8. Okay, so basically I'll just refer to this. This is S, capital S, small n, small a, small o, small e. Okay, so we can see how we want to step it. Alright, next we'll go back to this factorial example now. We will use a for loop to solve this question. You realize that many questions can be solved using both a for loop or while loop, or even you can use recursion. Right? So how do we use a for loop to solve? Because remember, factorial is just 6 times, let's say factorial is 6, that would be 6 times 5 times 4 times 3 times 2 times 1. But I could also start with 1, so 1 times 2 times 3 times 4 times 5 times 6. Alright, so this factorial rule, this is how we will do this. We're going to define factorial n. Okay, we're going to define the product first. Product equals to 1. Note that I never really use a counter here, but if I want to, but here I use the word counter. But remember, this is just, the counter here is just refer to the loop variable. You can use any name you want. You can for I in range 1 to n plus 1. Okay, I know that for factorial, I will start from 1 and then go all the way up to n plus 1. So this means that if I have factorial 6 here, this will go n plus 1 be 7. That means the stop is actually at 6. Okay, so this is actually 1 to 6. Okay, 1, 2, 3, 4, 5, 6. So I will increment the product by multiplying by the counter. So counter will take the value of 1 first. So 1 times 1, now it still becomes 1. Then my counter take on the next value, which is 2. So 1 times 2 becomes 2. Counter takes on 3. 2 times 3 will give me 6. 6 times 4 will give me 24, and so on and so forth until I get 720. Okay, so this will run for how many letters? You can run for 1, 2, 3, 4, 5, 6. Okay, after this, once you reach 6 here, you will get out of the loop and then you return your product. Okay, so it does not include n plus 1, yeah. Okay. Okay, once again, you can see how this code is executed. We start with product equals to 1, and then for I in range, now using I, yeah. For I in range, so first is I equals to 1, because I starts from 1, product is also 1. Okay, then I multiply it, then I advance my I to 2, then now it's 1 times 2. Okay, advance I to 3, so it now is 2 times 3, 2 times 3 will give me 6. Okay, advance to 4 will be 6 times 4 will give me 24. Advance to 5, that will be 24 times 5, that will give me 120. Last advancement, because it's factorial 6, so this is until 7. So factorial 6 will be 120 times 6, that will give me 720. So once I reach the 6 loop here, right, I will stop it already, because I will only say that I want to loop it 6 times. Okay, and then they will return me 720. Okay, so let's look at this iterative process again. So when we do factorial 6, right, what we're doing is this. We have taken the number of steps we've taken is proportional to n. So if we count this, there's 1, 2, 3, 4, 5, 6 steps, because we started from here. So 1, 2, 3, 4, 5, 6, right? That's when we stop. Okay, so if you were to increase n, you realize that the number of steps will be proportional to it. Okay, so if you increase n to 20, this will be 20 steps. Okay, space required constant. Okay, what does it mean? Okay, space requires looking at the number, how much data is stored, how many variables are you storing? Are you creating extra variables as you go on, or are you creating extra data as you go on? But in this case here, right, it's a constant. Why do I say that? Because remember, your n here is a product, right? So each time you're just updating the value of product by 1 times 1 give you 1 times 1 give you 1, and then 2 then you have 1 times 2 that will give you, so sorry, the next round will give you 6, and then next round will give you 24, next round will give you 120 and 720. I still only have one variable here. Okay, so the total number of variables I'm using is still just 2, product and counter. Okay, so the space required is constant. Alright, there are no deferred operations. Remember for recursion, right, we are, when we do recursion, let's say we do recursion 6, we are saying that 6, sorry, when we do factorial 6, right, that will be 6 times factorial 5. We are not doing that multiplying by 6 first, we keep it for later. So there's no deferred operation here. Every operation is carried out straight away. Okay, so all relevant information is contained in variables, right? Okay, next let's talk about break and continue. Break and continue allows us to interrupt the loops when certain conditions are met. Okay, so what exactly is break? Okay, break when it happens. Okay, so for example, for j in range 10, print j. If your code is this, then you will print, if let's say you just stop here, print j, you'll print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. However, if you see this line bottom, if j equals to 3, you will break. When you break, you essentially break out of the entire loop. That means you stop the entire loop. Alright, so if you think about this, right, this code will print, okay, so you just check first, it starts from 0. Okay, 0 will be printed, okay, that's fine. Then next one will be printed, 1 will be printed as well. Is 1 equals to 3? No, so you continue to run. So now you go to j equals to 2, we will print 2, that's fine. Is 2 equals to 3? No, so you continue. Then now j is assigned to 3 is assigned to j. Print 3 is j, which is now 3 equals to 3. Yes, so break. So you will break out of loop and your code will stop here and your loop will stop here. You will go to whichever block that is next, that is outside of this loop. Alright, so that's break. Okay, so also there's continue. Alright, if you look at this, for j in range 10, if j modulo 2 is equals to 0, continue. Alright, when you continue, what it does is that it will not execute anything below it. Okay, so in this case, if j modulo 2 is equals to 0, continue. That means it will not run the rest of the code for that loop. So look at this, let's just show you the result. Okay, so I will start with 1. Okay, I remember I start with 0. Okay, if I start with 0, 0 modulo 2 is equals to 0. Yes, it is. So it will continue. That means it will not print, it will not come to this line, it will not print 0. So now j goes to 1. Is 1 modulo 2 equals to 0? Is not, so it will not clear this. It will not get trapped by this. It will print 1. Okay, then 2 is even number, so it will stop here. And then you advance itself to 3. 3 will not get stopped by this if condition here. You will reach this line here, print j. So you can see that basically I'm skipping all the even numbers, because for all the even numbers that are caught, they are basically under, they are put, you do a continue. So continue will just skip that iteration, then move forward to the next round. Okay, so you can see the difference between break and continue. Break basically breaks out of the entire loop. That means it stops the for loop or while loop process. Okay, but continue will skip the current iteration and move on to the next one. Okay, so depending on your use case, you will have to use them accordingly. So let's say if you want to stop the code once you hit a certain number or hit a certain value, use break. If you want to skip some numbers, you use continue.